Today's little subject is called experimental probability. Anybody know what that means? We have two different types of probability. We have what's called theoretical, and we have experimental. And the difference betwixt the two would be, work with me here please, Rye.
Theoretically, it's like if you have one pass, you get one time and the other time.
Theoretical, yes, is the mathematical formula of predicting there. In other words, if I asked you what the probability of flipping a head is, the theoretical probability of flipping a head on a coin is 1/2. That's what the math says should happen. Experimental probability, though, children, is what really happens when you do the experiment. What actually happens. Okay? If I do, if I flip a coin 10 times, there's a good chance that I end up with heads 7 times. So the experimental probability of that would be 7 out of 10 when I did the experiment. Okay? Now, as a side note here, okay, the reason why this probably wasn't the experimental and the theoretical are a little ways apart is that you didn't do the experiment enough times, probably. As you continue to do an experiment, if I did 1,000,000 times, maybe I get 500,200 times a head comes up, which is awful close to half. The more you do an experiment, usually, the more the experimental and the theoretical are going to come together, and it's actually going to be very close. Hence the reason why the lottery works. I mean, they figure out the theoretical probability that somebody's going to win. Okay, does somebody win? Usually, sometimes, yes. That kind of goes against this, but they know after enough times experimental that you can never beat the numbers. Okay, you'll never, in the end, the odds will always beat you on that. Now, some things, though, when you figure probability, can't be done theoretically. Like the probability of Caleb making a free throw. Okay, how do you come up with a mathematical formula for Caleb's ability to shoot a free throw? Yeah, take the one out of the food court. I put the stuff in it, so it's good. You can take it. Thank you, Salvador. Okay, so the only way to come up with Caleb's probability of making a free throw is have him shoot free throws, and then you've got the data that you can make a probability out of. And Caleb, what would you say if I had you shoot 20 free throws? What would be realistically? Don't be like, yeah, I'll make all 20 because I've seen you shoot free throws. I don't think you'd make 20. You might not. What would you suppose you would make? Hold on. Okay. So this, after you do it, this is his probability. What's the probability he's going to make his next free throw? It's 11/20ths. If you'd have said 10/20ths, I would say 1. You could reduce it down to 1/2, but and that's what baseball. When we give batting averages, you are giving the probability that that guy's going to get a hit, because he's established that if he's batting .302, that means the probability is 302 times out of 1,000. He's going to get a hit, or his probability is close to 3/10, or 1 out of every 3 times, really, he's going to get close to a hit. So here is an example. Example about theoretical probability. A softball player gets 21 hits and 60 at bats. A softballer gets 21 hits in 60 at bats. Express the probability they will get a hit the next time up. Express the prob of getting a hit the next time. Good way to spell that. As a decimal with 3 decimal places. As a decimal to 3 places. So your probability is 21 out of 60. You can't change that. What's the easiest way to make that 3 decimal places? What would you do? Just divide it out, or reduce it before you divide. You're going to have to divide the bottom into the top. I would divide them both by what? 3. We get 7 over 20. Take 20 into 7. You end up with what? 0.36050. So the probability is 0.350. Or batting average. That person is batting 350. Average. Would be. Any other ones you think they would have there? Yeah, look at page 403. Look at example B with me. Read it to yourself as I read it aloud. Quinn runs a sandwich shop. Since she added a turkey melt to the menu, 36 out of 120 customers have ordered the new sandwich. What is the probability that the next customer will order a turkey melt? What is that probability? What? 36 out of what? 120. Okay, you want to change that into a fraction. Which ends up being what? If you reduce this, divide them both by 6, you get 6 over 20. Divide them both by 2, you get 3 out of 10. There's your probability, 3/10. Letter B says, ordinarily 200 customers on a busy afternoon, how many should she expect to sell? If your probability is 3 out of every 10 and 200 people come in, how would you figure out how many people would get that? You want to know what 3/10 of that is. So it's a simple multiplication problem. 3/10 equals, well, 3/10 times 200 is, what's that? 60, I believe. 60 people should get that. Or you could do it as a proportion. If 3 out of 10 people get the sandwich, how many would you get it out of 200? It's the same thing. Times 20 times 20. Everybody's pretty happy about that? Love it. Let's stop right there so you can have some fun and excitement.